Welcome, everybody. Good morning. Welcome to this inaugural Analysis, Design, and Architecture Conference. Not to repeat a lot of Sanal's speech, but before we get started, please thank the organizers, the people in mustard shirts, for putting this together. It takes a lot of work to put on a conference, especially a brand new one. They've done a stellar job, and we all collectively hope they can do this again. I am personally looking forward to lots of insightful talks, a really great hallway track. Hallway track is important. Engage in it, please. And I am here to talk about architectural decisions. So we'll start with a definition of a decision. Decision is a conclusion or a resolution reached after consideration. It is also a choice that we make after contemplating a few options. It's basically a fork in the road where we have to pick a path. As software engineers, we're pretty used to thinking about forks in the road. That is what we do with code all the time with our if statements and our loops, is we drive down a particular path to reach that conclusion or resolution. We even think of decision trees as a metaphor for going down those multi-pronged paths, those multi-pronged branches, to get to an outcome that we want. There is an important but implicit, not very obvious component to a decision, and that is intentionality. Decision is a choice made after a consideration, and there's an understanding that that choice is intentional. I make many small decisions throughout my day, like what should I have for breakfast? And I make an intentional choice about my breakfast. Any guesses what that might be? By the way, since it's after breakfast for everybody, small digression. When I was working on this deck, I prompted my favorite AI image generator with the most decadent breakfast pastry that you can have, and then I had some fun with it. Add some chocolate drizzle, some powdered sugar. And then I came here and I went to a croissant shop, which apparently is well known in Melbourne, and I bought stuff and I took a picture of my breakfast and it looked better than this. So congratulations, Melbourne, you won at breakfast. All right, so now back to decisions. Decisions are clearly important. We talk about them a lot. I talk about them a lot. But why are they important? Well, it's the consequences. Decisions have consequences. The consequence of my breakfast choice was an energy drop 2 hours later. I probably would have been better off with a healthier breakfast. But we're not here to talk about my mundane breakfast choices. We are here to talk about architectural decisions. So what makes a decision architectural in nature? There's a few definitions that float out there. Neil Ford thinks of architecture and decisions within it as those that have significant trade-offs, that are high in effort, and that are strategic in nature. Michael Nygaard has a more nuanced definition where he thinks of architecturally significant decisions as those that affect any of the 5 properties. The structure, the non-functional attributes, so these are your abilities like your performance, your scalability, and so on. Interfaces, dependencies, kind of the flip of interfaces, and construction techniques. When I think about decisions more broadly, what I realize is pretty much all decisions you're going to encounter in software development are going to be architectural in nature. It's just a matter of degrees. Why? Well, if you're writing code and if you have more than 2 lines of code, it's going to have structure, which means it has architecture. And if you're making a decision that's impacting that structure, then you have an architectural decision. We make many small architectural decisions throughout our day. How do I name that variable? I might argue that's not necessarily a small decision, because what are the 2 hardest things in software engineering? Cache invalidation and naming things, yes. Should this be an if or a case statement? Should I put some air handling here? If you're asking yourself that question, the answer is very likely yes. But that's not what we think about when we think about architectural decisions either. We think about something bigger, like what programming language do I use? Is this going to run on premises or in the cloud? Should this be a monolith, or should I lay out some sort of a services architecture? This gets at a very important property of decisions, the property that's going to affect so many things down the line, and that is its size. And the very first thing the size of the decision is going to affect is the size of the consequences. It's going to be proportional to the size of the consequences. The bigger the decision, the bigger the consequences. So I don't know if you're all familiar here with Southwest Airlines. It's a US-only airline carrier that operates in, well, you guessed it, southern and western United States, where I happen to live. The picture on the left is AI rendition of what happens when you continuously deny budget for software improvements for multiple years. By the way, good luck prompting that into your AI image generator. It took a while to get something like that out. And the two pictures on the right are very real-life consequences of what happens when that software implodes at one point. There's cascading flight cancellations for multiple days. People are stranded in airports over holidays, their luggage is lost, and any bad consequence of travel that you can think of happens. On top of that, a few executives walked out, and Southwest pledged $1 billion, that is billion with the B of US dollars, in order to get their software to some sort of a functional, reliable state. So pretty big consequences to those decisions. Implicit in the architectural decision is going to be your ability to change or reverse it. Renaming a variable or changing an if to a case statement is certainly going to be a lot easier than swapping out a whole programming language, migrating to the cloud, or breaking down a monolith into microservices. Mind you, none of those things are impossible, but the cost of doing those things can be pretty high and often unpalatable to the business, especially if the decision to go a particular way was fairly recent. And I know recent is a fuzzy word, say within past 5 years. What's going to be more expensive to change? Is it the paint on the walls or that very intricate tile on the floor? The cost of that change is going to inform, first of all, how often you can do these things, retile or repaint, and how much you should agonize over each of those decisions. We make many small architectural decisions throughout our day, but actually very few big ones throughout our career. What that means is it's actually pretty rare that we practice as making big decisions as architects, making it difficult to build that muscle. On top of that, gaining decision-making expertise is actually an even longer process. It takes a while to find out how well your decision played out. There's this feature of big decisions, and that is their impact in the long term. The cost, the value, the health of the system become visible in the long term. Certainly your if versus case statement isn't going to have much impact in the long term, unlike, say, monolith versus microservices decision. So, take some time to find out how your decision played out, realize the benefit of it, or understand the detriment, which means that gaining decision-making expertise is a much, much longer process. The size of architectural decision is also going to be proportional to the number of variables that you consider in that decision. You can think of it as a trade-offs to work through. Your paint is going to have two variables, roughly speaking. It's going to have the color and the sheen. And the color is going to affect the look and the mood, and the sheen is going to affect your ability to maintain the paint and clean it. Tile, on the other hand, a lot more. You have the color and material and the pattern that you want to install and the size of grout and all sorts of stuff. You can probably tell I've remodeled once or twice. And many of those have secondary considerations. Your material is going to affect the cost. Marble is going to cost you more than ceramic. Your pattern is going to affect the installation price. The more intricate, the more it's going to cost to install. And of course, the most important but least visible secondary variable of them all is whether your significant other likes it. So big decisions are infrequent, making it hard to build the muscle and build the expertise of those. They are choiceful, which is a funny word to describe the number of choices to make sense of within a decision. And they're consequential, not just for the system, but for a decision maker. Make good ones, get promoted. Make bad ones, get fired. All of that makes them very daunting, very scary, and, well, makes them difficult. Small decisions can be made intuitively. Have you ever found yourself in a situation where somebody brings a choice to you and you go, ooh, let's do this thing, that's a good idea, or ooh, yeah, bad idea, let's not do that. Before you can even articulate why it's a good idea or a bad idea. I actually find myself in that situation quite a bit. I have this immediate gut reaction to a particular choice, and I don't even have reasons in my head yet why I reacted that way. But I always like to find out. I like to reflect. And that usually happens at the end of my day when I'm driving home as I think about why I reacted the way I did. And usually what comes up is a number of lived experiences that then form into reasoned arguments for that reaction. And I know the definition says without the need for conscious reasoning, but it does exist. It's just really lightning fast in the moment and almost subconscious. It takes a real pause to surface it out. Intuition really is built on your experience. So my take on this definition is a little bit different. It's like this precognitive response derived from sum total of your lived experience. While we can make small decisions intuitively, can't do that for big ones. Those need something else. Why can't we do this intuitively for big decisions? Why doesn't it work? Well, we don't get to make a lot of big decisions through our career, not enough to build up so much experience that we have that intuition, that expertise already in place. So we need something else. We need big things in order to make big decisions. We need two big things to make decisions. We need skill and we need power. Power is a really big, very important topic. Lots and lots to unpack there. The person who's going to do that for you today is Andrea Magnorsky in her closing keynote. I am very much looking forward to what she has to say there. But I am here to talk about the skill. And this is a great news for all of us. Decision making is a skill, not a talent, not magic. It's a skill, which means it can be taught, it can be learned, it should be practiced to get better. Second piece of good news is you're not doing any of this alone. If you are, you're probably doing it wrong. Every step of the way, you're engaging with a group of people that's going to help you through that step and on to the next one. Third, with architectural decisions, as with everything else, you get better results if you have a consistent process. A heuristic or a framework is going to give you that consistency and help you make better decisions over time. Worth saying that no framework is going to be perfect. You all work in different places. You have different needs and considerations, so adjust accordingly. But a framework is going to help you avoid more common pitfalls. And that is what I'm here to talk about today. I'm going to be super brief with my introduction since we already did that. My name is Sonya Natanzon. I'm a software architect. I lead engineering teams. I've spent majority of my career at this point in healthcare. I love when people get in touch with me. LinkedIn is the way to do it, so please do that. And I can't deal with a ton of complexity. I realize I'm probably in the wrong business for that, but I try to make things as simple as possible and without further ado, let's decomplexify the topic of architectural decisions by breaking them down into 8 steps, starting with the first one, which is formulating a problem statement. So how many times have you been in the room where engineers are arguing about technology? Let's move this to the cloud. Or, getting popular now, let's repatriate it from the cloud. Or, another one that's popular now, let's use AI for that. And you're wondering, what problem are we trying to solve? Engineers are detail wranglers, as they should be. They can't wait to get into the weeds and start solving those problems. That is what they're incentivized to do. That is their job. But getting quickly into the weeds, we tend to lose forest for the trees. Mixed metaphor, basically we lose the overarching context and the bigger goal. So before you engage with any solution, formulate a problem statement. That is a foundational step to decision-making process. It gives you a clear objective, a North Star to which all of your solutions should be aiming. It gives you an ability to question every solution with, how does it help me with this particular problem? Charles Kettering, who was a head of research at GM, once said that a problem well stated is a problem half solved. So how do you state a problem well? I use this very simple but very brilliant heuristic by Seth Dobbs. And it says that a problem statement should have one of 2 things, either good outcomes that aren't happening or bad outcomes that are. That's all it should have, and we can try that in practice. Here's a potential problem statement. We are losing $25 million annually due to bad billing practices. Has a bad outcome that's happening, makes it pretty clear where we want to go from here. We want to stop losing $25 million annually, or maybe get that number down to something business is willing to live with. Clear goal, ability to question every solution with, how does it help me with this $25 million loss? Here's another potential problem statement. We need a new billing system. My knee-jerk reaction to these types of statements is, why? Why do we need a new billing system? What good outcomes will start happening, or what bad outcomes will stop happening if we get a new billing system? Unclear, other than we'll have a new billing system. So what do we have? Well, this is a real problem statement. Do we know what a solution is? Is it a new billing system? Maybe. Or maybe it's a retrofit of an old billing system, or maybe something else entirely. The point is, we have an objective to reach, and we're free to explore the solutions to get to that objective. What about the second one? Well, you guessed it. It's a solution in search of a problem. If you're finding yourself with something like this, stop. You probably don't have an architectural decision to make. You are being presented with a solution as a foregone conclusion. Why? Not sure. Maybe it's your boss's pet project, maybe something else. But the point is, there's no outcomes to drive to other than the one that's already built into a statement, that getting a new billing system is the outcome. A quick corollary to the problem statement heuristic is a heuristic to recognize a solution statement. And more or less anything that starts with "we need" is going to be a solution statement. You can try that. We need to use AI. All right, so I'm spending a long time on the problem statement, and I do recommend you do the same. You're going to need to keep coming back to the problem statement throughout the life of your project. And if it's a good problem statement and a problem worth solving, there's going to be a project to solve it. And you'll have to keep coming back to it for several reasons. One, to justify that very project and anything you might need for it. Engineering time, budget, tooling. Second, to validate information, assumptions with your stakeholders. And last but not least, to keep that North Star very shiny for your engineers so that they don't get distracted with other shiny things. All right, so now that we have a problem statement, it's on to the solutions, right? Not just yet. Before we get to the solutions, we first need to identify our last responsible moment. In other words, you're asking yourself a question. When do I need to make that decision by? But why ask that question? It's our decision. Why can't we make it whenever we want? In fact, why not make it immediately? Time is short, project time is always too short, and we want to make some progress quickly. Well, early in your decision-making timeline, you have not a lot of information, but seemingly a lot of options. We know that information accumulates over time. It also changes over time. Some assumptions might get invalidated. Others might take their place. So your information is pretty limited and unstable. What that means that decisions taken early are hugely risky and very likely will be up for rework. That adds time, that adds cost, and that dings our reputation, which is not great. In that case, why not make a decision when we know absolutely everything about this project, about this decision? When is that, by the way? Never. I love hearing never. Lots of truth in never, but there is a time when we get to that. Our hindsight is always 20/20, so somewhere at the end, we know most about it. But unfortunately, somewhere on this decision-making timeline, time starts eliminating options for us until we're left with only one, the one that fits into the remaining time. And you end up with a decision by default. We all know that decisions made by default, especially by time, are rarely the best ones. In fact, they're frequently ones that have a long tail of rework following the main project. So, the last responsible moment is that balance point between having the most information available and the most options still open. Where it's very, very illustrative, I notice, is build versus buy decisions. You're looking to potentially consider buying something, a framework, a system. You want to make sure it's a good investment, it fits your use case. You want to do a lot of research, but you don't want to stay researching it so much that when you do decide that it's a good decision to buy it, you no longer have time to implement it properly. So it's a good place to have it. Last responsible moment is a technique of delaying decisions until such time that a cost of not making a decision is equal and about to be greater than cost of making a decision. The real life example that I like to give is, let's say you interviewed for a job and you got an offer. That comes to you with a very explicit and real last responsible moment, and that's an offer expiration date. Do you want to make that choice immediately? Maybe not. Maybe you want to negotiate for more money with the new gig. Maybe you want your current company to give you a counter. Maybe you're waiting for that really annoying colleague to put in their own notice. Regardless, you want to make a choice, the most informed choice possible, while having an option of still taking that new job. So what is the last responsible moment really? Well, it's the first biggest and costliest constraint for you to identify. It is also a really nice mechanism for surfacing all the other constraints related to this decision. Notice that we almost never talk about a single constraint in isolation. Your budgets, your timelines, your technologies, available engineering teams, long-term business strategies, non-functional attributes and quality attributes, all of those are talked about together and all of them play into the decision that you're making. I personally love working with constraints. Constraints help precisely because they eliminate options. A field that's too wide open is actually really difficult to find a right path in, and constraints help because they narrow that path. And your business is going to have some very, very real constraints, always. But the challenge with constraints is they interplay. They are very much like a Rube Goldberg machine where you put something here, something over there is going to fall down. Finding the relationships and interplays with your constraints is the hard part. If you look closely, your very first constraint, your last responsible moment, is already an interplay between available information and available options, and they all get just more complicated from here. All right, so coming back to our problem statement of losing $25 million annually, working with our stakeholders and engineers, we come up with our last responsible moment and other constraints around it. I highlighted that 6 months. That seems important. Maybe something bad happens after 6 months, like the company goes under. But all of these constraints will need to be considered in your solution. So now that we have all of our constraints in the last responsible moment, it's on to the solutions? Not yet. Before we engage with a solution, we need to think about how we're going to evaluate the fitness of a solution to the problem statement. What are we going to explicitly evaluate, and what will we deliberately ignore? I tend to sit on a lot of design reviews, and the question that I always ask is, why does one choice preferable over the other? And the answer I often get sounds something like this. Well, this one is performant, but that one reuses code. I don't know about you, but it doesn't help me any to know why one is a better fit than the other. Is performance important? Is code reuse important? If they're both important, why aren't we considering both of them for all options? If one of them is not important, why are we considering it at all? To avoid these types of apples to oranges comparisons, you need to think about those important things for evaluating your solution and come up with evaluation criteria. And those usually fall into 3 different categories. 1, how does this solve the problem? I know this sounds very basic, but you'd be surprised how many I've seen that don't address the problem statement either in part or at all. 2nd, does it address the constraints? Remember, we have all of those constraints now, and they act as this multi-dimensional scale where some of them are going to be more important, more rigid. Others are going to be less important or more flexible, but we still need to address all of them. And last but not least, does it satisfy your quality attributes? So quality attributes, your LEDs, are constraints in their own right, but not the ones that business is going to bring to you readily. If you ask your business people, do you want the solution to be performant and secure? They're going to say, yes. But how performant and how secure, and can you have more of one at the cost of less of another? That's your job to figure out, and this is the detailed work that you're doing to strike that balance and figure out the relationships. There's going to be other quality attributes that your business won't even know how to think about if you don't put it in the more relatable terms. What does that mean for code to be maintainable? It means we don't have to hire 4 more engineers next year to keep it running? Okay, so we're going to do that thing then. I mentioned earlier that not all evaluation criteria is going to be made equal. Some is going to be more important, some is going to be more rigid, others less so. How do you incorporate that into your evaluation? Assign relative weights to each criteria that will indicate the importance and rigidity of each criteria. The higher the weight, more important, less flexible it is. So, coming back to our problem statement, we took our evaluation criteria and we assigned some relative weights. This will help us evaluate the solutions that we come up with against the importance of that criteria. All right, so now that we know how we're going to evaluate our solution, it's on to the solution options, right? Yes, yeah, we got there. So this seems like the most important part of the process, but this is actually the one I'll spend the least time on. Why? You're all very senior. You know your space better than I do. You're all eminently qualified to come up with the right solution options. A few things to keep in mind when you do so. Generate more than one option. A very, very smart product manager once told me, if you can think of one solution, you can think of more than one. Your peers, your stakeholders, your boss will really want to know that you truly thought of and considered more than one option, not just your favorite one. Don't go too far beyond 3. I like 3 as a number in general, but going far beyond 3 tends to induce analysis paralysis. People tend to get lost in a nuance. The other thing that starts happening is you start creating variants of the main option. So you get the 2C and 1B and so on. If you find yourself in that place, it's a good time to sit down and do some work of elimination. Some of those variants are going to be non-viable, so prune those off. Others might replace the main options, but it's a good time to get back to some manageable and distinct number of options. Last but not least, come up with at least one radically different option. This tends to be a good exercise to try and keep yourself out of your own and hopefully somebody else's bias. Maybe you already had a favorite option, favorite technology in mind. Maybe your boss who's bringing you this decision also is bringing you a vendor they want you to use. Coming up with a radically different option at least helps bring people back to the table and make them consider those alternative angles. So, coming back to our problem statement and losing $25 million annually, we have 3 different solution options now. We have a brand new billing system that we can build for it. We can retrofit the existing billing system. And our last radically different solution, notice it's not even a software solution, it's a people and process solution. We think we can put a dent in this by getting a new role in and training up the rest of the team. So, we now have the solution options onto the decision, right? Not yet. First, you should get some advice. So I made this step separate, mostly to call attention to it, but what happens in reality is it's pretty well meshed together with the previous step of solution making. You tend to create solution options, you ask for advice, maybe prune off some variants, ask for more advice, and it's well embedded together. But we'll call it separately here. A quick reminder, this is your decision. Your organization empowered you with it, or maybe you're an accidental architect and it just fell in your lap, but regardless, this is your responsibility to make that decision. But also, remember those decisions are consequential, with maybe consequences to a decision maker, and you're responsible for the decision and its consequences. Well, the good news here is you can and should get some advice. Who do you ask for that advice? You should ask 2 groups of people. First group is a group of those who are materially impacted by your decision. Who might that be? Really? Anybody. Maybe another engineering team that's going to have to consume the changes to the API that you're making. Maybe it's customer service group that's going to have to explain the new user workflow to your users. Maybe it's marketing team that needs to create new promotional materials for the changes that you're making. So anyone impacted. Second, those people with expertise in your decision space. So these are folks that might have done something like this before, maybe stepped on a few landmines, and hopefully live to tell the tale. The list of people can get long. Don't stress about that. That just indicates the importance of the decision. The bigger the decision, the more people that are meaningfully affected by it. Hopefully, the bigger the list of people with expertise to ask. Don't shortcut the process. Last thing you want is for your decision to get reversed if you didn't consult somebody who may no longer be able to consume the changes that you're making. The other place where it gets important is regulated space, because you might be inadvertently stepping on some local regulations that you're not aware of. What do you do with all the advice that you get? Well, this is the beauty of advice. You don't actually have to use it all. Some of it might be useful information, but not applicable to your situation. Maybe that person with the expertise in your space Maybe they did the same project with huge budget and tight timelines, and your situation is the opposite. So great story, but not quite applicable. What you need to do is you do need to seek a broad range of voices. Don't be looking for confirmation bias. I know it's nice to hear those things, but look for a broad range. Do process it and understand the advice's applicability and record it. That's all you really need to do. This is not my invention. This is something that was originally coined by Andrew Harmon, and it's called architecture advice process. I really love that process because it allows the architect to go seek the information that they really need to make their decision while keeping the decision-making agency with the architect. Side note, Andrew is just about to come out with his new book called Facilitating Software Architecture. It is probably the most in-depth work I've seen around architectural decisions, so when it comes out, highly recommend you check it out. So, now that you've been advised, decision time? Well, no. Now you're ready to evaluate your solution and perform your trade-off analysis. The good news here is you already have your weighted criteria for performing that trade-off analysis. What you need to do first is assign yourself a scoring system. Have fun with it. It can go to 11. You can use negative numbers. Totally arbitrary. The second thing you need to do is you need to score each criteria, but not just score it, justify each score that you're assigning. This is where it gets interesting. This is usually done in a group, not alone, and the debate here can be pretty hot. And one thing that often happens is you need to change the weights that you originally assigned to criteria. Not always, but sometimes that happens. Oh, I thought we might have some flexibility around budget. Nope, we actually need to fit into the number we've been given. No more flexibility. So the weights change, something becomes more rigid. Coming back to our problem statement and our 3 solution options, we go ahead and score these on a scorecard. And once we total up our weighted totals, we find something really interesting. A radically different people and process solution ends up scoring the same as retrofit of an existing billing system. What we notice is we still get the biggest value out of a new billing system, but maybe we can do something different here. We know that retraining is pretty fast and pretty cheap. We can get a good dent into that $25 million loss by retraining, but we can use that to start building our long-term solution of a new billing system. All right. So now that we've been armed with some valuable insights from our trade-off analysis, what's next? Well, it is decision time. By now, a recommendation most likely emerged from your trade-off analysis. Maybe a couple of options are close. Maybe there is a clear winner. Maybe we come up with something unique and interesting like this hybrid solution we came up with now. But you likely know what the next right step is. You've done the work. You can show all your work. And I'm sure you have a recommendation in mind. So go with that. That's all there is to a decision. Once decided, record your decision. I know a lot has been said about architecture decision records, so I am going to be fairly brief here. Architecture decision records reveal the intentionality behind the decision, and they help eliminate a question that invariably pops up down the line. Is this a feature or a bug? I hope you guys have seen this before. This is actually a real picture that has floated around for a long time. This is one of my few not AI-generated pictures. This is real. Somebody had a very, very geeky sense of humor. The record is not important now when you're making that decision. The record becomes important later when the long-term consequences hit. And people start wondering why a particular decision was made. The record helps to obviate the why. It shows them what the problem statement was, what were the constraints and considerations, and it now gives them the long-term effects of that decision so that those that can come after you can make a better informed change. It really lets those that come after you have your experience without having to go through your experience. So, in order for that to happen, you have to write it down. But you've been writing things down all along, right? Yes? Yes. Yes. That's what I wanted to hear. Yes. Well, in that case, congratulations. Good news for you. Your decision record is almost complete. They all follow a very similar template. They will need your problem statement, your context, your constraints, your trade-offs, all of those steps that we've just gone through. You do need to add a few more things. One, the actual decision that you're making. Two, the reasons behind that decision. And the very important 3 and 4, positive consequences that you expect out of this decision and negative consequences you accept. Every decision is going to be a trade-off, and this is the explicit statements of the trade-offs that you're making. This is the area where, is this a feature or a bug? Question pops up the most in the trade-offs that you are explicitly or sometimes implicitly making. And now, congratulations. You made a decision. Be confident, stand behind it. Nothing worse than flip-flopping on decisions. And you might have made a tough choice. Options might have been close. Maybe your peers or your boss had a preference for another solution option. But decision needs to be fixed so that development can move forward. There are times, occasionally, when you may have to reevaluate your decision. This last step here is conditional. And the condition under which you reevaluate your decision is when material new information comes to light. What is material? Material is anything that would have affected your choice, made you take a different fork in the road, in your steps 1 through 6. The easiest litmus test of materiality I can give you is this. If, as you're learning that new information, the first thought that pops in your head is, I wish I knew this when I was making this decision, it's material. This is why I recommend writing things down all along. It actually lets you go back very quickly and see, is this something you already considered? Sometimes people don't like your decision and they keep bringing things up, and it's good to see, ooh, we thought about this already. Or is it truly new and needs consideration? I recommend taking your material new information and going all the way back to the problem statement and pressure testing problem statement and all of the rest of those steps with that new information to see if a new fork in the road emerges. But do that much faster since you already have a big foundation available to you. All right, so with that, remember, to make big decisions, you need those 2 big things, skill and power. And now for skill, you have a framework of 8 steps that will give you some consistency in making decisions, and with practice, will let you make better and better decisions over time and make the process a lot less daunting. So, thank you.